Hello class, in this lesson 1.7 average rate of change, you will learn how to find the average rate of change of a function and also which is equivalent to finding the slope of a secant line. So let's begin by first reviewing or discussing what the average rate of change is. Now for linear functions, what you learned in Algebra 1, that lines, linear functions, their rate of change is constant. That is referred to as the slope. That is a constant rate of change between any 2 points. So regardless of what points you have, that slope of that line rate of change is always going to be constant. However, if you have functions that are not straight, like this parabola right here, then the slope between the 2 points is going to be different depending on the 2 points that you use. So like if I use this point here and this point here, the slope of this line is going to be different than if I would pick up this point down here and this point up there. That's going to give me a different slope. So as a result, we refer to this as the average rate of change. Now, the line that we create on these nonlinear functions, this line again that intersects again these nonlinear functions, are referred to as secant lines. So like this line here, highlighted in red, that is referred to as the secant line of the function. And obviously there's an infinite number of secant lines we can draw. Like I said, we have this possibility here in red, but we could also have this possibility right here in blue. And because we're using 2 different points for a nonlinear function, the slope of these secant lines are going to be different. Now, what's the formula in figuring out the slope of this secant line, or the average rate of change? The way that we calculate the slope of the secant line, which use m for slope, and we use the abbreviation secant here, that is equal to this formula here. So on an interval where a and b are the x values excuse me, that we're interested in, we find the slope by getting f of b, subtracting f of a, and dividing it by b minus a. So the difference between those two evaluated, the function evaluated at those points. This should look somewhat familiar. If you recall from Algebra 1, you have actually used this formula before. This is simply your slope formula. Notice that f of b, again, is the same thing as a y value. So if I use a as my x1 and b as my x2, because those are what they are, they're x's, then f of a is simply my y1 value, and f of b is simply my y2 value. And substituting that into this formula instead simply then means that we're using this formula here. So this slope average rate of change formula for our slope of our secant line is the equivalent as the slope formula that we use for linear functions. The only difference in today's lesson is that you're not going to be provided the y2 and the y1. We're going to first have to calculate that using a graph or using a function rule, and then simply plug it in again to this here, to that formula, to our y2 minus y1 over x2 minus x1. So let's look at an example. On this example right here, we're looking at this parabola on the interval of negative 2 to positive 1. So remember, this is not an x and y value. These are both x values. So this is my x1 and the 1 is my x2. So plotting those points on my graph, at negative 2, when x is equal to negative 2, the y value is positive 1. When x is equal to negative 1, I'm sorry, positive 1, not negative 1, positive 1, the y value is negative 8. So here are the 2 points. So negative 2, our y value is 1. Positive 1, our y value is negative 8. So that just again simply means in very layman's terms that we have are x1, y1, x2, y2. So using again just essentially the slope formula, we'll get the slope of our secant by getting -8, subtracting it 1, y2 minus y1. That's all I've done right here. And then x2 minus x1. So 1 minus -2. So we have -9 on top, +3 on the bottom, and this divides to -3. And that's the slope of this secant line right there. So those 2 points again connect to make a straight line, and that is my secant line, and the slope of the secant line is -3. You can again then count, if you remember using rise over run, you'll see that it goes down 9 units, it goes over 3 units, and that simplifies to 3 over 1. -3 over 1. Let's see, let's look at another example. So here's similar situation. These again is my interval, so my x1 and my x2. So at x1 of -2, we have this point there, which is at 1, 2, 3, -2, +3, and at 0, we have that point right there at 7. So we have the ordered pair of -2, 3, and the ordered pair of 0, 7. So again, f of b minus f of a divided by b minus a, which again is just essentially, in very simple terms, means that we have x1, y1, x2, y2. So this formula is the same thing as this in red. So simply using that format and that idea related again to what we've done in Algebra 1, we can figure out the slope of the secant, the average rate of change between those in that interval, by subtracting 7 minus 3 in our numerator and 0 minus -2 in our denominator. So we end up with 4 over 2, which is equal to +2. So this is the slope of our secant line. Now, if we're not provided a graph like in this example, instead we're provided the function rule, we still need to do the exact same thing. Figure out what the y values are in order to determine, again, f of b and f of a. So here we have the function rule, and we're looking at finding the average rate of change, the slope of the secant, in the interval of -1 to 2. So these are my x values, x1, x2, and we're going to first figure out what x of -1 is. So simply substituting -1 into my x's. Remember that -1 to the second power is +1, but because of this negative sign, it's going to keep this number as -1. Now simplifying this even further, this is going to end up becoming -21. So f of -1 is -21. So when x is -1, the y value is 21. So that's my x1, y1. Now I'm going to look for my, I know that x2 is 2, I just need to figure out the y2. So I do the same thing. I now evaluate my function at 2. So I replace now all of the x values with 2. And I get -4. And this is equal to -4 plus 12, that's equal to 8. So -6. So there we can then just plug in again, plug into our slope formula. So the slope of our secant will be -6 minus -21, 2 minus -1. So like I was saying, -6 minus -21 is 15. And then 2 minus -1, that's equal to 3. So that reduces to 5. So that's the answer. That's the slope of the secant line. That's your average rate of change of this function between these two x values. So it's increasing 5 units per every unit, again along the x-axis, between -1 and 2. Let's look at a different example. Here in example number 4, again, these are my x values. So at -9, we're interested in figuring out the y value. And for -7, we need to also figure out that y2 value. So that requires us again to simply evaluate our functions at those respective values. -9. So 2 times -9 to the second power, that's equal to 81. 28 times -9, that's equal to -252 plus 93. Well, 2 times 81, I should have done that also. That's equal to 162. So now subtracting 162 by 252 and then adding 93 gives us a total of 3. So that's the y value for x is -9. Now let's evaluate the function at -7. So 2 times -7 to the second power plus 28 times -7 plus 93. Now -7 to the second power is 49 times 2. That's going to equal to 98. 28 times -7. That's equal to -196. Add the 93. And then 98 minus 196 plus 93, that's equal to a total of -5. So that's the second y value. And now that we have those, we can figure out the average rate of change by using again our simple slope formula. -5 minus 3, -7 minus -9. So -8. +2, and our answer is -4. Let's go through a couple more examples again. So on this example, same thing. We have 4, we need the y2 value. We have 7, we need our y1, I'm sorry. This is going to be our y2, and then we can figure out the slope of our secant. So really, just more than anything else is knowing how to evaluate properly our functions. So we end up with 64, 32, 36, and then plus 1. So then this simplifies to -3, and then evaluating, so that's the first y, and then to evaluate our function at 7, which would be 7 to the third minus 2 times 7 to the second minus 9 times 7 plus 1. That's going to end up equaling to 183. So that's our second y value. So then subtracting 183 minus negative 3, 7 minus 4, we end up with a total of 186 over 3. And that, well, let's divide that out. 186 divided by 3, that's equal to 62. So there's your answer. Let's see a couple more examples. I'm going to skip example number 6, and I'm going to jump to number 7. Since number 6 is pretty much another polynomial, just substituting in again, raising to the right powers, and then adding these together. Let's do number 7. Number 7, again, we have that the x value is 2, and the other x value is 8. So we're just missing our y1 and our y2. This is our x1, our x2. So we're going to start by evaluating f of 2. So this would be 2 minus 4 divided by 2. Again, replacing all of the x's with 2's. 2 minus 4 is negative 2. So this is going to simplify to negative 1. Now let's do the same thing with 8. So 8 minus 4 divided by 8. 8 minus 4, that is equal to 4. And 4 divided by 8 is equal to 1/2, or the decimal 0.5. And then plugging this into our formula to find our secant, we're going to get our 0.5 minus negative 1 and divided by 8 minus 2. 0.5 minus negative 1, that's equal to positive 1.5. 8 minus 2, that's equal to 6. And this is going to equal to a total of 0.25, which is the decimal equivalent, well, is the equivalency to the fraction of 1 over 4. So either of the two answers would be suffice. You could either write the decimal 0.25 or the fraction 1 over 4. And then finally, one last example, the one with, let's do one with square roots. We can even figure out, again, this is non-linear, so we can figure out the average rate of change, our slope of our secant, by using the same strategy as before. So we have our x1, we don't know what the y1 is. Our x2 is 4, and again, we need to find our y2. So let's evaluate our function at negative 1. So the square root of negative 1 plus 5, we would add the two numbers together first, which is before, and the square root of 4 is 2. Let's now plug in 4, and we would add again the 4 and the 5, which is 9, and the square root of 9 is 3. So the slope of our secant would be 3 minus 2 divided by 4 minus negative 1. And 3 minus 2, well, that's equal to 1. 4 minus 1, that's equal to 5. So we have the fraction 1 over 5, or the decimal equivalency of 0.2. And again, you can leave your answer as a fraction or give it to me as a decimal. Either one would work. Well, there you go. And this is how you figure out the average rate of change. So in very simple layman's terms, what we're simply doing is just simply figuring out the slope of a secant line. These 2 points are going to connect to intersect our graph somewhere in between there, but in between the graph itself, so it's not going to connect again in a constant rate of change, but the line that we create again does have a constant rate of change, and that is the average rate of change of the entire function in between these x intervals. But the slope of our secant line is equal to this 0.2 for this specific example. Well, again, thank you again for watching. If you do have any questions, send me a message to remind, and I hope you have a wonderful day. Thanks. Goodbye.